Hey young biologists, this is video 1.2 on basic stats and graphing. Parts of this video might be review, but it's good to all start on the same page since we'll be using these core skills in AP Bio all year. The video covers these three topics. Pause if you'd like to take a closer look. One of the most useful statistics in science is the mean. For our purposes, the terms mean and average are essentially the same. By definition, a mean is a statistic that uses all of your data points to calculate one middle number. To find a mean, add together all of the data points, then divide by the number of data points or sample size. In AP Bio, you'll get a formula sheet on the AP test and on each class assessment. Here's the formula on the sheet for the mean. Mean is represented by an X with the bar on the top. But if you're not confident with math symbols, this formula can be crazy confusing. The good news is that you've calculated averages in school for a while, so you likely don't need this formula. But I really want you to understand why we're using these stats. For the mean, the purpose is to generate one number to represent the whole data set that can be consistent of a bunch of different numbers. Then, if you have two data sets, you can compare the means of both data sets as a first indicator to see if there's any differences between those data sets. We're going to use this example of some made-up quiz scores. To calculate mean, add up all of the quiz scores. 68 plus 79 plus 62 plus 77 plus 12 equals 298, and with 5 numbers in our data set, divide by 5 to get a mean of 59.6. Another common stat is the median. Just like the median generates a middle number to represent an entire data set. You calculate the median by lining up your data points from least to greatest, then figure out which number is in the middle. Also, like the mean, the purpose of the median is to give one number to represent all of the numbers in the whole data set. The mean is more commonly used than the median, but if there are a bunch of outlier data points that are really high or really low, then the median comes in handy. Let's look at some examples. Let's calculate the median on our quiz scores dataset. First, line up the data points from low of 12 to a high of 79. Next, cross out the lowest and the highest value. Cross out the next lowest and the next highest until I only have one middle number left. This middle number, 68%, is my median for this dataset. Let's try a second dataset. First, put the data points in order from the least to the greatest, and then cross out the lowest number and the highest number until there's one middle number left. But what if there's two middle numbers? Well, in that case, just find the average of the two middle numbers. So the average of 73 and 87 is 80, so the median of this dataset is 80%. Now let's talk about graphing. The two main graph types we'll make in AP Bio are bar graphs and line graphs. To know which type to make, check out your independent variable. In general, if the IV is qualitative, like categories, use a bar graph. If the IV is quantitative, use a line graph. In this example, the experiment is, what is the effect of light color on photosynthesis? The IV is light color, a qualitative category, so you'd use a bar graph for this one. In the bottom example, the experiment asks, what is the effect of light distance on photosynthesis? The IV, light distance, is quantitative, so you'd use a line graph for this data. All right, back to our quiz score example. What is the effect of quiz topic on quiz scores? The IV quiz topic is qualitative, variables or stats, so a bar graph is best for this data. Now that we know the type of graph to use, we still have to set the graph up. To start, what goes on the x-axis and what goes on the y-axis? The independent variable is typically plotted on the x-axis, but there are some instances where something like time is on the x-axis. If you have trouble remembering which is the x-axis, think about how when you have to take an x-ray, often you have to lay down flat, just like the x-axis lays flat along the bottom of a graph. The dependent variable is typically plotted on the y-axis. If you have trouble remembering which is the y-axis, think about how the side of the graph is like the stem of a capital letter Y, like I put here, or that the y-axis goes up and down, just like a yo-yo toy. A mnemonic memory trick to help me remember which variable goes where is dry mix. Dry mix means the dependent variable goes on the y-axis. Sometimes the dv is called the responding variable, so dry means dependent, responding y-axis. Now, the independent variable goes on the x-axis. Sometimes the independent variable is called the manipulated variable, so mix means manipulated, independent, x-axis. Let's make the graph. Let's first use dry mix to add our axis labels. Dry dv on the y-axis, mix iv on the x-axis. Oh no, don't forget to add the units. There's our units %. Then we've got to break up the axes with proper scaling. This is a 20 by 20 grid, so I'll scale the y-axis so that each box represents a 5% score increment. There we go. I didn't label every box, just kind of every fourth box, and then I'll put the independent variable along the x-axis, and now it's time to plot the data. There we go, some nice bars, and then finally title the graph with a scientific title. The easiest way to make a scientific title is to use this format. The effect of blank on blank, where the IV is first. Remember, the I in independent looks like a 1, and the DV is second in that title. So that's a good title for this example. There it is. This is a good graph to clearly communicate our data trends. So let's recap. First, we covered the basic stats of a mean and median, both important to generate single numbers to represent the entire data sets for easier comparison of one data set to another. Next, we talked about how to determine if you should use a line graph or a bar graph by considering the independent variable. Third, you can use dry mix to help you remember that the dv goes on the y-axis and iv goes on the x-axis. Finally, the effect of iv on dv is an effective template for a scientific graph title.